Hi everyone, this is Jordan Nanos. In this video I'm going to review some of the code that I used to create the text-to-SQL example using Open-WebUI pipelines. As you can see on screen, I've got a repo on my GitHub, example pipelines, and for this one I've set up a special Open-WebUI environment that I'll use to walk through the three different pipeline examples. Specifically, I'm going to cover a repeater example, which is really just the absolute simplest pipeline I could create to explain how to set things up. Then I'm going to cover the text-to-SQL pipeline using a VLLM endpoint with the Llama 3 8B instruct model and Llama index for doing the natural language query against a SQL database, which happens to be Postgres, and the data inside is a open data set that I got on Kaggle of Wikipedia movie plots. Somebody, Justin R, has gone out and scraped the plot summary descriptions from Wikipedia of almost 35,000 movies. So we're going to use that data set to provide an example that we can chat with natural language being converted into SQL queries. In my case, I happen to be hosting my endpoint remotely using a tool called the HPE Machine Learning Inference Software. It's using a VLLM compliant runtime, but you could really be using any, it's using the VLLM runtime, which is OpenAI compliant, but you could really be using any OpenAI compliant endpoint or any OLLAMA endpoint in here. The example that I've got in the pipeline just happens to use the Llama index library OpenAI-like, which works with VLLM. The third one here is the 02 SQL query pipeline. In my experience, when I have a LLM generate a SQL query and then return a response, sometimes I just want to make a quick edit to the SQL statement and then run it against the database again. So in this case, I kind of shortcut the actual need to query the LLM before or after going through this. So that code's available now. If you just want to go review the code, you can go check out this repo. I've also got a directory called data where I've got the CSV file from Kaggle right there, and the statement around the open licensing. And then in my case, I was setting up PostgreSQL on a Kubernetes cluster, so I just took some notes here on how to install Postgres on micro Kubernetes. So let me just do a quick demonstration of what this looks like. Basically, as you've seen with Open-WebUI, you can chat with any OpenAI compliant endpoint. And in my case, the testing here I'm doing is on a single machine running micro Kubernetes, which has a single VLLM endpoint running this Llama 3 8B instruct model, the open one from Noose Research. And it is actually running on an L4 GPU, so 24 gigs of GPU RAM. Maybe a little bit slower than a 4090, but it's equivalent to what many people will have at home instead of needing big H100s or something just to get started with this. So obviously we can do more than this. What I've done in the environment is, if you go to the admin panel and you click on settings and then connections, you'll see that there is a connection set up to the pipeline service or the pipeline container, right here, pipeline service, pipeline container. When you're deploying Open-WebUI on Kubernetes, this will be done by default, or you'll configure it in the Helm chart. If you run on Docker, you'll need to run the pipelines container outside of that. If we click down here on pipelines, the Python files that are in our pipelines container or pipelines deployment on Kubernetes are either uploaded here or installed from a Git URL. So I guess you could use my Git URL. I've just been clicking to upload the Python files after cloning the repo to my laptop. So here I've got three of them. If we flip over to VS Code, you can see I've got the repo here locally, and I'll just review the most simple one. In the repeater example here, we basically start with the class pipeline, which is required in any pipeline file. And we define 4 functions: init, on startup, on shutdown, and pipe functions. Init is simple in this case. I'm just giving the pipeline a name, 00 repeater example. The reason you give pipelines a name is because if I pop back over here to a new chat window, if I click on this drop down, you're going to see it's going to show up with that name, 00 repeater example. And then what this pipeline is doing is basically just taking any message it receives and printing it back to the web interface. So if I type in hello, it's going to add the string received user message from user hello. It's just going to repeat things back to me. So it's a way of getting an understanding of what a pipeline actually does, and to kind of understand that there's basically arbitrary code execution that's being done in this file, so be careful. But also, you need to follow a little bit of a format here. Basically, you'll need to pass in, you'll need to, well, you don't have to do anything with, but any input from a user in Open-WebUI is going to be a string called user message. You may define the model ID that's being used, and you may define lists of messages, and then the output is going to be a union of string generator and iterator from our import of typing up here. So that's it. That's the most simple Open-WebUI pipeline that I can manage to create. One that's a little more complicated is my text-to-SQL pipeline that's here. In this case, I've got a number more imports. For example, we use psychopg to connect to the Postgres database. We use Pydantic to define our class of valves, which is inputs with basically information about my database that I'm connecting to, or my VLLM endpoint that I'm using to do the text-to-SQL. Then we've also got Llama Index in here. So I've got a few different Llama Index libraries that are actually going to connect to the VLLM endpoint, serve a query, get a response, and then this natural language SQL table query engine library from Llama Index, as well as the core libraries of prompt template, SQL database. They are all in here. SQL Alchemy is actually used to create the engine to connect to the Postgres database as well. Before I review this code, I just want to show the quick way in which I've uploaded to Postgres and where I can review the data. I'm using dbeaver, so it runs on the client side on my laptop, and you can see kind of the same data set that I would have shown on Kaggle. In this case, the movie release year, the title of the movie, where it came from, like its origin, the name of the director, any notable members of the cast, the genre, the link to the Wikipedia page, as well as the plot. And so you can get a sense of how this might be similar to some sort of database that organizations are using and would like to open up to people who maybe don't have a bunch of SQL experience to run some queries and get some understanding of what's inside. Okay, so in this case, the first thing that we need to do when we define the class of pipeline is define a class of valves. This isn't required, as you can see back on my repeater example. If I drag that over here, it's not required to have a class of valves, but it is useful. And specifically, why it's useful is because you may be changing the database, host, port, username, password, which table you're querying, which host you're querying, like which VLLM endpoint you're using during the query, without actually wanting to upload a new Python file and define a new pipeline itself. We can actually kind of see this if I click back to my admin settings into pipelines. If I switch from repeater example here to my text-to-SQL VLLM pipeline, you'll see that my specific IP for the host, the port, user pass, database, tables, the host for my VLLM endpoint, my dummy API key to replace the OpenAI API key, and then the specific model I'm using. These are all defined here, right? And if I were to want to change them, I could, as a user, change them on the user level using the concept of a valve without needing to actually upload a new pipeline at the admin level. If I go down here, we're initializing a database connection using this function. Specifically, we're grabbing the connection parameters from up in our valves there. We're creating the connection using CyclePG, and then I'm printing out the metadata about the database to the logs. I was using this for some debugging when we were creating the pipeline, logic itself. If you want to get these logs, Docker logs for the pipeline container or kubectl logs for the pipeline deployment. We still have an on startup and an on shutdown method in here. Specifically on startup, I'm calling the function initdb connection here so that it's persistent in the pipeline. And then I'm running something on shutdown. We've got some extra functions that'll be handled here in the main. So let's go back up there when we're done reviewing here. But basically in the pipeline file, we've got, we're creating an engine. We're connecting to a database using the Llama Index SQL database library. We're creating an LLM component here. I really should be using my valves here, but I guess it's still hard-coded in my file. One thing to note about Llama 3 is that you will need to include these stopping IDs if you want to have a short response, like a proper response. Otherwise, you're going to get an endless completion. And so these are the stopping IDs that have been defined for the Llama 3 and 3.1 models. But then if you want to use the stopping IDs properly, you'll need to actually customize the SQL prompt. The basic SQL prompt, text-to-SQL prompt that comes with the Llama Index libraries needs to be customized to include these header tokens to describe that here. You can see my text-to-SQL prompt, review that, make a modification. But the place in which it's used all the way down here is when we create the query engine. This is the really important line. We're using the Llama Index method or library, natural language SQL table query engine. We're passing in the information from the SQL database, which is defined higher up as a SQL database object in Llama Index. We're passing in the LLM, which is an LLM object from Llama Index. We're choosing to use a local embedding model here. I may modify that in the future as we improve performance on a specific data set, maybe fine-tune an embedding model. But for right now, I think the local one is BGE, which is good enough for a demo. And then the text-to-SQL prompt I've defined here as, again, the prompt template object from Llama Index. So synthesize response I've turned off for right now. What that means is that when a SQL query actually runs, it's just going to run and display the raw output, as opposed to displaying the output and then trying to have the model synthesize some sort of response. I created a mock synthesis prompt here, which could be changed if you set this to true, and then you set that to be equal to the synthesis prompt here with another prompt template object of synthesis prompt. You may be able to modify that. Finally, I've got streaming set to true. There's ways to play around with streaming here. This should really be set to false. It's not being used, and we're not really handling the streaming response, but I left that code in here in case you wanted to explore the output from a streaming perspective. Okay, so back over here to just do a quick demonstration of this. I showed the repeater example, so let's switch now from repeater to the database RAG pipeline. How many comedy movies in the 80s? So this is a question of just like a SQL statement, right? Somebody may be able to generate that, but select count star from movies were release year between 1980 and 1989 and genre equals comedy. I'm a little bit familiar with SQL, but it was much quicker to just generate that right now. Let's see. So if we do, instead of doing how many, we just say comedy movies in 1989. Let's see what it comes up with here. Great, so we've got Beverly Hills Brats. We've got The Big Picture. We've got Breaking In. Breaking In looks interesting. We've got the plots here, right? But let's see. So in breaking in, it looks like we've got the plot and we've got a director, Bill Forsyth. So movies directed by Bill Forsyth. Looks like he's directed 2 movies, Breaking In and Housekeeping. So just as an example, while I'm doing this demonstration, instead of doing 0-1 database RAG pipeline, let me switch to database query. And before even reviewing that code, let's just show why this is different. I can copy this SQL query here. I said just select distinct title from movies where director thing. Let's select the plot and let's remove the limit 5. I mean, it doesn't really matter, but in this case, now we've got 2 plots, right? So which of these are appropriate to watch with children? So there we go. A bit of a workflow that you might see with a user where they start out running natural language questions, getting a SQL query, running it against the database. Then they convert to modifying the SQL directly, run it against the database, and now they take a raw output, which maybe is much longer than just these 2 movies by this director, Bill Forsyth, and instead they actually use a natural language output here. So there we go. Looks like Llama 3 recommends that I watch the movie Housekeeping as opposed to the movie Breaking In tonight if I'm looking for a classic comedy. Okay, decent demonstration to show the response. Let me just finish by reviewing the code in the SQL query pipeline here. It's simpler than the first example. Why? Because we're basically skipping all of the interaction with the LLM. You'll see my imports. There's nothing with Llama Index here. And no SQL Alchemy stuff and all that. But it basically the main function here, pipe, is just going to establish a connection using CyclePG. You may want to modify this if you've got MySQL or you've got some other SQL database. This is specifically for Postgres. You create the connection. You turn the user message that's coming in directly into a SQL statement. You execute it. Then you return the string. So a relatively simple pipeline that kind of matches 0-0. I may recommend starting with 0-2 if you're just kind of troubleshooting, connecting to a new database. If you're trying to upload some new information, maybe you're following along with this little tutorial here using my movie plots, and you just want to create that connection and identify things. One last thing to mention, just because I didn't, I included in here kind of a recipe to pip install Llama Index. It can be a little bit finicky since they broke up the library into multiple different subcomponents, I guess. So the recipe that worked for me, pip install Llama Index core, LLMs OpenAI like. Then you reinstall this package NLTK that Llama Index depends on. Then you install the OpenAI like library again. And the last thing I responded, I included a SQL query to list all column names in a table, so that, for example, if you're testing this guy out, you may want to run this sneaky guy and identify the column names. Okay, hopefully this review was useful. Let me know in the comments if you got any feedback or questions, or you want to send me a PR and expand on these examples, see something different beyond Text-To-SQL. But thank you for taking the time to watch this today.